So this is my starter project, the mini POV. This is my main project, the self-balancing robot, basically. So I'll start off with a mini POV. So I'm just going to say beforehand, this broke. This was when I was really good at soldering this. And for those who don't know what soldering is, it's basically where you use you melt some metal and you stick it onto this board. But anyways, so what this does probably doesn't look like anything right now. POV stands for persistence of vision. So have you ever seen those things that shake back and forth that lights up and it makes like a word or image or something? So this is basically a really simple version of that. So we have 8 LEDs here, and I can program this microcontroller, basically like a small computer, to turn these lights on and off really quickly. And if I shake it, you should be able to see a word. Batteries go here, and right here, the serial port is where you connect to the computer. Now, unfortunately, I can't show you anything because it's broken, but I did take a picture before, like 5 weeks ago, so I think I'll show that. And it actually looks a lot better on picture, so let me see. So I thought it was a short word, prompt, simple. Fortunately, it's too late for me, but for the guys out there, gave everyone an idea. Okay, so yeah, that's my starter project. Now my main project is the self-balancing robot, essentially a small Segway. So I'll explain a few of the main parts. So the Arduino, there's a chip right here, you probably can't see it, but this is the IMU. And within the code, there's something called a PID controller, which I'll explain later. So the Arduino is in most of our projects, but it's it's also kind of a microcontroller board, really easy to code, and this basically acts as the brain of this robot. And it's connected to the IMU, which is the inertial measurement unit, which is composed of an accelerometer and a gyroscope. And accelerometer, it's kind of self-explanatory. It measures acceleration. But for this purpose, it's to measure the orientation of the board. And the gyroscope is, well, it's something that really kind of spins normally. But it's something that helps measure the angular rotation. So, if it's going like that, you can measure that. And finally, the PID controller is something a bit more complicated. PID stands for proportional, integral, and derivative. So some calculus in there. So basically, it measures the current error, all the accumulated error, and finally, it kind of predicts the error in the future because of the derivative. But using that, it helps stabilize what angle this stays at. So right now, I still need to work on this, but I got it to a pretty good point. So I'll try to demonstrate that. See if it's cool. So it will be really jerky, but let's see if it works to a good amount. Let me retry that. It's really jerky. It's getting there. It's getting there.
That's awesome.
Yeah! Yeah, so hopefully in the future it won't be like, everywhere, like it's spazzing out. But yeah, those were my projects. Does anyone have any questions?
What's the utility of this?
The utility? So what kind of applications? Well, segways. That's a big one that everyone knows about. There are several other ones. Like Perrine showed me one where there's this. It's basically this. Bigger motors, looks better, and you can stick an iPad onto it, and it extends up and down, so you can do like FaceTime with others, and it balances itself and moves around. I'm not sure how many other applications there are. I can't think of many, but I don't know, it helped me understand a lot about like orientation, how it measures things. Like these IMUs are like in all your phones probably. Like it measures, you know, when the screen goes sideways and all that. But yeah, I'm not sure about any other applications. If anyone can think of any, that would be awesome. But
You can talk about the accelerometers and the gyroscopes. Where are they used? Like I talked about dogs and stuff like that.
oh, yeah. So apparently there's this an accelerometer that can be on a dog collar, I guess, and then like it can measure the like orientation of the dog basically, and then see if it's like sleeping or eating or and whatnot, and kind of monitors it. But yeah, so there are a lot of applications using just this chip.
The moment of inertia, I think the Segway is so big and the mass is so large that the angular change is slow with time, and this is like super fast. So
Yeah.
I don't know how you can even, if you get it to work, it's amazing.
Well, actually today I slowed it down. It was like, so like basically the PID, I'm going back to the PID controller, but so it measures the tilt, the error in the tilt to control the speed and the direction of the motors. And then with that formula, it added onto the speed so much that, like before it was like 7 times like the square root of whatever formula calculated. That was like basically the max speed for this whole thing the whole time. And right now it's really simple, but I'll just work on reducing the speed. But yeah, so that's definitely a problem that I would like to fix.
This project must have been very hard. What was like the hardest part to get through?
The hardest part, I guess it's right now, the code, especially because the code is very, very long, and there was a lot of math that I did not understand, including the PID controller is sort of simple, but that wasn't the only thing. Like there was a lot of like gravity, like squares, and diagrams. I don't know, and there was a lot of also computer stuff like filters. Well, for those that don't know, filters, like low-pass filters, for example, they get rid of noise in the frequency, because the high-frequency stuff is noise, and it gets rid of that. But yeah, there's a lot of that coding stuff, and you know, even now, it still doesn't work completely. So I'd say the coding portion was the hardest, and besides that, some other milestones I overcame include things like making the gyroscope. So like if I tilt, I made a program where if I tilt this a little bit before it was attached, it made the motors move. Like it was really important that this works in coordination with the motors. So those are a few of the things that were the hardest part of my project. But definitely the code. I've learned a lot of code after just these 5 weeks. Yeah. Any other questions? All right, thank you.